In this video, we will look at how to compute space complexity. Space complexity is the amount of memory needed by an algorithm to complete its execution. That is, how much space is consumed in the main memory during execution of an algorithm. When an algorithm is implemented as a program, the program will occupy computer's memory. The program's memory structure consists of instructional space, data space, and environment stack. The instruction space is the space needed to store the program's instructions. It depends upon the compilers, interpreters, or how program is converted into executable code. The data space is the space needed by the variables, constants, and dynamically allocated objects. The environment stack, also known as runtime stack, is used to store the local variables, formal function parameters, and return addresses. The environment stack can grow depending on the function calls, or in case of recursive function calls. Therefore, the space needed or consumed depends on the following components, that is, the fixed part and the variable part. The fixed part is the memory or space needed for the code, that is, the instructions, space for simple variables, and space for constants. Whereas the variable part is the memory or space needed by the referenced variables and the recursion stack. So, the total space consumed or needed is the sum of fixed and the variable part. Therefore, the space requirement is a function S of P, where P is an algorithm which is equal to the sum of C, that is the space needed for the code, or the fixed part, which is constant, and the space needed for variable part represented by SP. Now, when we analyze the space complexity, we only care or concentrate on the variable part, that is SP. So, for a given problem or algorithm, we need to determine the amount of space needed by the variables. The basics is that we want to know how much bytes or words an algorithm or the program is using during its execution. Therefore, in terms of bytes, we have to consider typical memory usage, which is dependent on machines, and which programming language is used to implement an algorithm. But typically, we assume that the variables of the primitive data type consumes one word. And then many algorithm uses arrays. For arrays, if there are n elements or items, then depending upon the data type, we have to multiply the amount of memory n times. Now, since we are assuming that the primitive data types consumes one word, so if there are n elements in an array, we assume that it consumes n words. The same is the case for two-dimensional arrays. That is, the number of elements in a two-dimensional array is the amount of memory consumed. Let us consider an example and mathematically compute the amount of memory consumed in execution of an algorithm. For example, let us look at this algorithm ABC. This algorithm uses three parameters, and if we assume each parameter uses one word in the memory to store the values, then since these are simple variables which uses fixed part of the memory space, and we are not concerned about the fixed part, which is constant, and there are no reference variables or local variables used in the program, therefore the memory consumed by this algorithm is 0. Let us look at another algorithm MAX and compute its space complexity. This algorithm finds the largest element from the set of elements. Here we have result as a local variable which consumes one word. Then we have variable I in the for loop also as a local variable which also consumes one word. And we also have n in the for loop which also consumes one word. So the for statement consumes 1 plus 1 or 2 words. Then finally we have A, which is an array of n elements, which will consume n words. Therefore, the total memory consumed is n plus 3 words for the input array of size n. So this is how we can compute the amount of memory consumed or space complexity of an algorithm. Just as a point to remember, typical memory usage is dependent on computer machines and the programming language used to implement an algorithm.